All right, so now let's talk about the element argument. So in general, what you want to do is you want to show that X is a subset of Y. And you don't want to do it element by element, because what if X has an infinite number of elements? So how are we going to proceed in that case? So we're going to do the following. We're going to suppose that X is a particular but arbitrary element of the set capital X, and then you're going to show that this element is an element of Y. And because this element was arbitrary, this is going to show that X is a subset of Y. So let's look at an example here, how to do this. Let's define sets A and B as follows. So A is going to be the set of integers M and Z, where M, you can write it as 6 times R plus 12 for some integer R and Z. And B is going to be the set of integers N and Z, where you can write N as 3 times S for some S and Z. So we're going to look at two parts. We're going to start with this first part. We want to prove that A is contained in B. A is a subset of B. So when we want to write this proof using our element argument, let's identify our starting point for this proof. Our starting point would be, suppose you need to take an arbitrary element out of A. So X is any element of A. And now, what conclusion are you trying to reach? The conclusion to be shown is that X is an element, X is in B. So let's write this proof now. Let's start with our starting point. Suppose X is any element of A. And let's go back to our definition of these sets. That means I can write this element as 6 times some integer plus 12. So I'm going to say since X is in A, X equals 6 times R plus 12 for some integer R. And now what I'm trying to reach, the conclusion I'm trying to get to here, is that X is in B. So let's look at the definition of B. In order to be in B, I need to be able to write X as 3 times some number. So how can I do that? Now, X equals 3 times what? If X is 6R plus 12, I can just factor out a 3 and get X is 3 times 2R plus 4. So I'm going to relabel this part in this parentheses now. I'm going to call that S. let s equal 2r plus 4. Is s an integer? The answer is yes. S is an integer because sums and products of integers are integers. Also, x equals 3 times s now. And that's exactly what we needed to get to say our conclusion. X is in B. And this completes our proof, so I'll put a square here to indicate that my proof is complete. All right, now part B, what I want us to do is disprove that B is a subset of A. So if we're trying to disprove this, what we want to say is that that's not true. So we want to show B is not a subset of A. So go back earlier to our definition. What does it mean to not be a subset? We need to find an element X so that it's in B and it's not in A. There's something in B that is not in A. So what did it mean to be in B? I want X to be in B, which means it needs to be 3 times some integer, but it needs to not be in A, which means it can't be written as 6 times an integer plus 12. So you're going to have to think about multiples of 3. Let's just go with, let's try 3. Well, this is 3 times 1. It's a multiple of 3. So X is in B. And the question is 3 in A? Can I write 3 as 6 times a number plus 12? So let's see, let's solve for R. Remember, R needs to be an integer. So all of these are multiples of 3, so if I divide my equation by 3, I'll get 2r plus 4 is 1. 2r equals negative 3, and r equals negative 3 halves. But remember, r needed to be an integer. So r is not an integer. Therefore, 3 is not in A. Okay. So I found my element that is in B. It's a multiple of 3, but I can't write it as 6 times an integer plus 12.